Alrighty, everyone. Good evening, everyone. This is meteorologist Timmy Albertson here with you guys. Welcome to tonight's weather chat. We are going to talk about a little bit about Tropical Storm Franklin. Of course, for those of you who have been tuning in the past couple of nights, not really much right now to talk about with Tropical Storm Franklin, but that could change as we head our way towards the weekend. The other thing we're going to talk a little bit about is, of course, that heat wave that has been making its way across much of the Midwest. We do have some temperature numbers in from that event, and so we'll take a look at that a little bit. And also, there is going to be the possibility for some strong storms out across the region. So, with that in mind, we are going to kind of take a look at that. Of course, those storms are likely going to be, well, over in the Ohio and Michigan area. In fact, they're probably going to start developing here in just a little bit. Actually, some of them are already developing. So we'll go ahead and take a look at that here. Just one quick moment here. I just wanted to check something on the old telephone. I know, very not necessarily very good of me to text while talking, but all righty. Okie dokie. All right, let's go ahead and take a look over at, we'll start off with Tropical Storm Franklin here. And of course, for those of you who are joining in, feel free to ask questions if you do have them. Always happy to answer those. So we're going to flip the screen here over and we'll take a quick look at Tropical Storm Franklin. Franklin is still having a little bit of a difficult time, but it is starting to get better organized, which is not really saying much given how disorganized it has been over the past couple of days. Convection is really present on the eastern, might actually kind of be pulling the center of this overall system a little bit towards the east there, which is kind of why it has that east-northeasterly track. That's a little unusual for this time of the year, especially for a system, tropical system that low in the latitudes. But it's not really getting much help from really anything else kind of right now. And because it's kind of disorganized, again, that's may kind of explain some of that easterly direction. However, it'll start to enter a little bit more favorable of an atmosphere as we head our way into the weekend, organize and eventually become a hurricane. And then it's going to start kind of making its way up towards the north as we're going to see this kind of upper level ridge on the eastern way off towards its east kind of develop, and we'll see a trough begin to make its way in from the upper Great Lakes, and that will kind of help Franklin out here a little bit. Right now, it looks like it's going to kind of stay just off to the west of Bermuda and kind of looking long range, albeit when it comes to tropical systems, you don't really want to look too far out because there's a lot of things that can change with them. Looks like it's going to kind of stay away from the East Coast and just kind of make its way up maybe into some of the eastern Canadian Maritimes way out in the open waters, but that'll be sometime next week. Again, things could change with that. So right now, mainly just going to be affecting, a couple of boats here and there and some fish in the sea, but it will still be kind of interesting to take a look at. And of course, we'll keep an eye on this system as we make our way forward, in the forecast. I don't know how I was trying to structure that sentence. So the other thing too, we're going to kind of take a quick little look at here is naturally, as mentioned, we did have ourselves quite a bit of a heat wave out across the Midwest, and it's still ongoing a little bit here. I am going to flip the screen here a little bit, so you're going to see the matrix here really quickly. And I didn't really have a whole lot of time kind of earlier on today to put this together, but here's some of the numbers, at least through across the upper Midwest. With that heat wave on Tuesday, a lot of places were well into the 90s. That includes La Crosse, and even St. Louis reached up to about 100 degrees. They were one of the warmer spots. Minneapolis actually managed to make it up to 98 degrees on Tuesday. That set a daily record. Yesterday, they got up to 98 degrees again. That I was down there for that. For a little bit, and that was also another daily record high. So Minneapolis set two daily record highs for the 22nd of August and for the 23rd of August. La Crosse, Wisconsin, really kind of beat out most of the cities here with at least routine climate observations at 104 degrees yesterday. That's what they got up to. That was by far a daily record for the day yesterday. Today they got to about 96 degrees. Milwaukee hit 101 yesterday. That too set a daily record high. Interestingly, though, their high temperature on Tuesday was 78, and their high temperature today has only been about 84 degrees. So maybe we'll talk more about that tomorrow. Kind of take a look at some of the charts there and see what was going on there with Milwaukee, because that's quite an interesting little jump there from going upper 70s to lower 100s and then back down into the 80s, given that other places around the area are much hotter. Chicago, over at O'Hare International Airport. Yes, on Tuesday got up to about 90 degrees. Yesterday they got up to 98. That was a daily record high for the O'Hare Airport. And then today, 100 degrees, at least when the early climate observation came out. We'll see if they end up maybe going a degree or two higher than that. Is well, it's about 7:30 there, so we're probably past well past daytime peak daytime heating, but maybe they managed to sneak out an extra degree. We'll know tomorrow for sure about that. Peoria, Illinois, not too far away, 99 degrees what they got up to. Davenport hit 100 degrees, but ironically, they did not break any daily records, at least as of yet. So the places, at least in the Midwest, that saw daily records broken were La Crosse, Milwaukee, Cedar Rapids, Chicago, and Minneapolis. And there's probably a few other little small towns here and there that might have also probably broken some records, but this is just kind of a quick overview. If you are familiar with your geography, you'll notice at the bottom of your screen there, Indianapolis and Toledo, they are further off towards the east, as we're kind of seeing that heat making its way just a little bit more towards the east. Indianapolis got up to about 94 degrees this afternoon. Toledo only got into the upper 80s, but we'll see too, obviously, if that ends up being their official high, as the climate report, I believe, came out maybe around 5 o'clock in the afternoon over there. So, it was still plenty of time for some heating. So we'll keep an eye on that. But overall, there's some of the numbers, certainly some unusually hot weather, regardless of the time of the year. It's not too often you see triple digits in Milwaukee or even really getting close to that in Minneapolis. So that's just kind of a look there at what happens. All right, let's go ahead here and take a look at the radar. We got ourselves a little bit of a thunderstorm event that is trying to set itself up, and this one might be pretty interesting to watch here as we go through the evening hours. Severe thunderstorm watch is in effect across extreme northern Illinois going into southern Wisconsin. That does include Milwaukee and the Waukegan area. It does not include Chicago. There are some storms there naturally. We'll take a look at some of these guys here, but kind of the bigger severe thunderstorm watch is the one that is over the lower peninsula there of Michigan. And this one is in effect at least for, well, probably another couple, at least a few more hours. I think it goes until, let's go ahead and take a look at the text here. I can't do that math in my head. 1 a.m. Eastern time. So midnight Central Time there. What's actually going to be happening here is that there is an expectation that the atmosphere is becoming a lot more humid in this area. There is a little bit of a frontal boundary trying to move its way through. I'm obviously just kind of glossing over a lot of the more details with this, but long story short, a little bit of an upper level disturbance swinging its way through. We got kind of a little bit of a frontal boundary trying to push its way through also, and we're likely going to be seeing more storms developing here, and this is likely going to become a line of storms as we head into the evening hours. And actually, the kind of trajectory here that we're kind of expecting is that these storms are going to push their way to the south and to the east, and could maybe bring a little bit of some strong gusty winds in some parts of the storm when it gets over towards Cleveland, maybe down towards Detroit too, and also other parts kind of around Lake Erie. So because of that, there is actually kind of an elevated severe weather risk kind of right around Lake Erie as we go through the next couple of hours. So it is going to be pretty interesting to watch. And typically what we see with this type of setup is these storms tend to fire up as individual little storms. And that's actually a lot of times when they produce their hail. And if there is a little bit of rotation, sometimes, they'll kind of manage to maybe, rotate a little bit initially. But once they all kind of conglomerate together into one line, it becomes more of a wind type of situation. And atmospheric conditions right now are actually kind of favorable here for there to be at least maybe some pockets of strong gusty winds with the storm line as it does make its way through. Of course, it's still kind of in the development stage. This is going to be what's known as an MCS. And I like to call these little guys night dwellers. They tend to do better in the evening hours and into kind of part of the overnight. There was one that made its way through eastern Ohio yesterday that we were taking a look at. That one is since weekend, and the atmosphere was appears that it was pretty well able to recover from that as we made our way through the day today. And that's kind of what we're going to be seeing here, at least a little bit. So again, there's kind of that weak area, that kind of frontal boundary, the same one that we were watching yesterday out in Minneapolis. Again, it's now trying to push its way a little bit more down to the south and to the east. Those storms kind of firing up more or less kind of right along it. And as we go through the evening hours, they'll likely start running into each other and kind of forming a little bit of a line here. And again, for those of you who kind of want to see a little bit of the meteorological synopsis of this, we'll go ahead and flip the screen here over to you, and we'll take a look. We took a look at this actually yesterday. So if you did tune in yesterday, you got a little bit of a lesson in the SKU-Ts. Again, this is Detroit's. This is a model expectation from the GFS, courtesy here of Tropical Tidbits, is the one who provided at least this graphic. And this is showing that there is, a lot of instability here. It's kind of continuing to get more unstable. Again, this particular image here is a model expectation, but, given that it's only about an hour out, we can kind of consider it, close, kind of close to what's probably the actual atmospheric setup. You got, of course, you're a little bit kind of a cap there, but once those storms are able to kind of push that, they just have kind of free roam, and that's kind of what that little purple dash line is. We call this Cape. It is the area effectively, north in this map, above the red line, I guess I should say. And Cape is a very good indicator in meteorology of atmospheric instability. Typically, the higher values of Cape that we do see, the more likelihood of severe and strong storms. It stands for convective available potential energy. That's what CAPE stands for. You've probably heard it before, thrown around quite a bit. If you've ever read weather office forecast discussions, or join me on one of my old Facebook lives from some of my old stations. Again, this isn't something that you would normally want to show on air because it takes some time to explain it, but this is one of the things that we do look at. And again, when we're dealing with, CAPE values that are, around 2,000, 3,000 joules per kilogram, I know that's a weird quantity, isn't it? That is a good indication that we're probably going to be seeing at least some strong storms. Another thing that we look for, if you want a little bit of a forecasting thing, is that one thing that when we're talking about the possibility for strong winds within a storm, especially when we're looking at squall lines, there's something called a downdraft cape, which is the D cape. If you look over on the right of your screen, you see all those, you see SB cape, that is surface-based cape, ML cape, which is mixed layer cape. That's mixing it from the lower levels. There's reasons why, but we won't talk about that now. There's most unstable cape, which is the MU cape. Below that, you see the blues. That is convective inhibition. That is a value that determines, more or less how much energy is going to be needed to overcome the stability, at least in that particular part of the atmosphere. Again, this is kind of an unscientific way of explaining it. Again, the value's obviously not as high, 140, and the mixed layer is only about minus 36. So again, a cold front or something along those lines would be kind of enough to obviously push that over. The D cape, though, that you see there at the bottom, the last blue one, that is what we look for sometimes when we're talking about strong winds. And that's about 1,400 joules right now per kilogram. So good indication that some of these storms might try to pack at least some gusty winds with them, at least when they get a little bit stronger. So that's just kind of the atmospheric setup for those of you taking notes. Otherwise, for those of you who, don't really care much about this particular type of thing, that's all right. It's not everybody's forte. This is just kind of the scientific thing, but I just figured I'd show you, kind of the atmospheric profile here, and at least some of the things that we're looking at. Again, this is for Detroit. Obviously, we're also expecting those storms to still be strong when they move their way over into the Cleveland area, but that will not be until later on tonight, as we're already seeing those storms still back over in the Michigan area. So I'm going to go ahead and flip back over the radar for you guys here so you can take a look. And actually, what I want to do, because I made this mistake last night, I didn't check the comments, and someone had asked a question there. So Alex says that it is some pretty warm temperatures yesterday. And actually, what was really interesting about that, Alex, is some places actually were seeing their high temperatures later in the day as that warm front was kind of pushing its way through. So that was kind of interesting. But what was also interesting, though, about yesterday, and I think I actually may have a graphic about this. Let me double check here, but I don't know if I put it in the show or not. Ooh, maybe I didn't, but let me see here if I did. Well, no, that was from yesterday. Sorry, everyone. I actually had a temperature kind of graphic for yesterday, but I'm not able to get it up here right now. But temperatures across eastern Ohio were noticeably lower, and part of the reason for that were those storms that they had make their way through yesterday ahead of that warm front. So that kind of kept them a little bit cooler, but it helped to add some moisture. And so now when the extra moisture moves in, there's already moisture there. And so again, it's actually surprisingly one of the contributing factors as to why stronger storms are actually expected. My hand's moving around a lot. Why stronger storms are actually going to be expected around the Cleveland area as we go into late this evening and into the overnight. So that's just kind of, more or less that. So a little fun fact for you there. As I said it probably multiple times before, everything in weather is connected. A storm in one area will always play a role, whether it's big or noticeable or not, but it is certainly still one nonetheless. So we'll flip back over here to the radar. And I'll check back in on those comments again. If you're watching and you have any questions or any comments, feel free to let us know, depending upon where you're watching from. Heck, if you're around the Michigan area, maybe you can let us know when it starts storming where you are. If we're still on when that does happen. Again, as I mentioned, this is going to be a little bit later this evening. At least the main event. What we're seeing now is kind of let's see, what's a good sports analogy? The first inning, I guess. And a lot of times in baseball, things don't happen for a few more innings normally, unless you get some blowout first innings that the pitcher ain't good. And I've seen some of those. But let's go ahead and we're going to flip back over to the radar. And whoop, there's the matrix. Let's flip back over to the radar here. And I take a look at this little guy, this little storm here. It is just north of Grand Rapids, Michigan. A nice little city. Ironically, that is one city in Michigan I have not been to. And I don't know why. But anyways, we got this little storm here. Let's see what the weather office at least has it warned for. And that's for the possibility of 1-inch size hail and maybe some marginally gusty winds within that. So again, as I mentioned earlier, one of the first things that we tend to see with these storms, these type of setups, is that when these storms first fire up, because they're what we call in meteorology discrete, which I don't like that term because thunderstorms are not discrete. They're very obvious. But just we use the term discrete to imply that they're kind of by themselves a little bit, not like what you'd expect when you have a line of storms where they're all right up on each other. When they first start off, and sometimes in these situations, when they're kind of isolated from each other, sometimes again they'll have a lot more of the atmosphere to work with. They'll have a little bit more time, and again, sometimes they might try to rotate a little bit, at least maybe form kind of somewhat of at least a little temporary mesocyclone or whatnot. And long story short, these guys can sometimes end up kind of producing hail, at least initially, and even sometimes it's not unheard of. Sometimes with these MCS events, is there is a little bit of a trail. There is a little bit of a tornado possibility with these guys sometimes when these storms first kind of fire up. So what you see here, by the way, this yellow shade, that is a severe thunderstorm watch. That little box you see there, that's slightly darker yellow, that is a severe thunderstorm warning. So again, right now, it's just kind of warned for the possibility for some hail. It does look like there may be some pockets of some gusty wind here and there. Let's see if maybe we can't kind of get a little bit of an idea, possibly about 13 meters, 14 meters a second. Convert that in the heads about times 2. So yeah, I mean, there's probably going to be at least a little bit in the way of some gusty winds with that. So just kind of watching these storms as they first do kind of fire up. So certainly very interesting. And again, like I've said, though, these are night dwellers. This particular type of situation, these storms are mainly going to be at the night. And I'll tell you what, here's one that's kind of interesting. And let's see, this is over near Chicago. Obviously, it's out over Lake Michigan, so it's not really affecting anybody right now. But I want to see here. Let's flip on the Chicago radar over it. Or is it going to be close to, it may be closer to Milwaukee's radar. Let's see here. Well, before we come back to that storm on Lake Michigan, let's start off with this little guy over here. This is on the Milwaukee radar imagery. And take a look at this little guy. You got this guy, and it looks like it has some gusty winds with it here. That's what it's warned for, the possibility for a little bit of hail and about 60-mile-an-hour winds with it there. Whoops, flipped off the radar by accident. Um, so again, that's kind of going to be the main thing, at least right now with these storms initially, is going to be, obviously the possibility for some hail. Now, again, we're looking pretty close here actually at the Milwaukee radar. So that's pretty nice, as a matter of fact. And, here's another thing too. We took a look at this yesterday. I always like to point it out. I know those of you who have probably watched this chat, multiple times before, you probably you've already probably heard me talk about this a couple of times, but it's always fun to point out on the radar imagery, there is an outflow boundary right here, right there. That little line you see there, that is rain-cooled air that appears to be kind of moving out ahead of the main line there. And this little guy kind of acts as a, very localized little cold front. And sometimes we can see new storms kind of developing along it there. And I have it, this little symbol here is the symbol for what we would call kind of a mesoscale front, more localized than it is regionally. There are little hash marks in there. But again, that's kind of what that's going to be acting as. So sometimes if those get a little too far out ahead, they can actually hurt the storm. But that's also a lot of times what gives you that nice little breeze when the storm first kind of moves in, that cool down there, and that's some of that rain cooled air. If we were to actually put this on a little bit of a loop, you can kind of see it moving out ahead of the thunderstorm. Let's hope the bandwidths today allow this to happen. Come on, load, 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 load. It's going to get there, folks. It's going to get there. We don't have a big budget to work with right now, so we take what we get. But let's go ahead here and see here. You can see it moving there. As soon as it's loading, that little blue bar at the top, it looks like it's really scared to go all the way to the right because it keeps going back and forth. All right, let's take a look here. As that storm kind of moves its way through, boom, there it is. You can kind of see it pushing its way down to the south as that storm moves in frame here. You'll see it right there. Follow my cursor. There it is. So that's a little bit of an outflow boundary. So again, we'll keep an eye on these storms here over the next couple of hours. Well, maybe not next couple of hours. We'll see what they do here again, kind of expecting that it's more or less going to kind of form into a line later on here. Let's see if we can't maybe take a look here. I want to see if is this little local radar close. Nah, that storm appears to be just far enough away that it's going to make it tricky for us to, see it here on the radar scan. Again, it's over the open waters. It probably does have a little bit of hail. Let's see what the Weather Service is thinking here. They have a marine warning out, so if there's anybody out fishing right now, let's see here. Wind gusts up to about 40 knots, so that would be about 45-ish miles an hour. And maybe some small hail. So again, that's kind of what they're expecting with that. So certainly maybe a little bit in the way of some decent waves. Let's see here. Is that happen to be a buoy nearby? I'm curious. Looks like it's right around an area where there isn't one. Because I tell you what, if that would have went over one of these little guys over here, that would have been kind of interesting to see some of the numbers it would kind of push out. And here's a fun fact for you, while we're on the topic. Fun fact is that a lot of times, and we see this with hurricanes and we see this with thunderstorms, the stronger winds tend to be over the water because there's less friction. So a lot of times, I know sometimes what you'll see is when a storm, a strong storm or a line or something comes off of the lake, and, like let's say Lake Erie, which is something that we could see later on tonight, those winds don't have anything to stop them as it's going over the lake. And so sometimes you can see kind of locally higher wind totals, not just all over the lake, but also kind of immediately inland from it when those storms first come on. So sometimes you see a little bit of an uptick in severe thunderstorm warnings or whatnot, depending on the office and depending on the situation. Sometimes you will see a little bit of an uptick in the severe weather warnings as those storms do come off the lake. And we kind of see that sometimes when these coming off of Lake Michigan into Michigan itself. And I've seen it sometimes around the Lake Erie area when they're coming off, getting towards Cleveland again. When we're talking about, less friction, it could be, the number off the top of my head, I would imagine probably anywhere between 10 and maybe 30 miles an hour extra, but it also depends on the system sometimes. But and with hurricanes, that's another thing that we see. Those strong winds when they're over the water, it can really be gusting, and when it slams into land, those winds will kind of carry over a few, a little bit inland, but really those strong winds tend to be the strong, right up against the water or over the water. And again, just has to do with friction. Land provides way more friction than uh, water. What's also interesting is that because the friction can also kind of help to turn the winds a little bit. But that'll be for another day. Um, but yeah, friction plays kind of a big role in that. All right, let's see here. Nope, no questions or comments yet. Okay, good. So I didn't miss any. I know last night there's a couple of them and I missed them, and I felt really, 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 really bad about that. So let's go ahead and we'll take kind of another look back here at the radar, and we'll take a look. I kind of want to keep an eye on this little storm again near Whitewater, back out in Wisconsin. Again, it's right up on the Milwaukee radar. Oop, I don't think I flipped it over. Did I flip it over yet? No, I did not. I'm sorry, everyone. Here I am having all the fun, and all you're seeing is me. So again, we're taking a look at it here on the radar imagery. Looks like it might have a little bit more wind with it now, but when I say a little bit more, we're still not really looking at very high values here, maybe kind of marginally close to severe, and yeah, maybe not. Might have been a little wishful thinking, at least for the moment being. Again, still kind of looks like it's going to be more so for hail. I think we might be far enough away for the VILs to work on this. Sometimes when you get a little too close to the radar, things get wonky with the signal, as you can kind of see there. But yeah, it does appear that there might be a little bit of hail here. And while we're on the topic, let's see here. I gotta remember which layer it is. Still working, still new, folks, with this system here. So let's see if we can't get some storm reports at least here from this. We'll see if we can get any type of we'll see if we can get some storm reports when they do come out here. So yeah, that'll be the local storm reports. Those will come through the National Weather Service. So I think we are good. So now we just kind of wait. So again, when I say getting a little close to the radar, part of it has to do with actually the way the beams work on the radar itself. That's a whole other topic for a different day, is how radars work. But you can kind of see a little bit here how it gets a little kind of weirdly shaped again when you get a little close to the radar. Things kind of get somewhat wonky, and sometimes actually when these things go over the radar, especially if it's a heavy thunderstorm, it can actually kind of block the signal just a little bit, and it can make things actually look a little bit weaker than they actually are, just because it's having a hard time seeing through it. And we see that every now and then, especially when you're dealing with heavy rain and stuff like that. With those storms. So this is VIL on the right, in case you guys are wondering. I just realized I probably didn't actually explain it at all. But VIL stands for vertically integrated liquid. Basically, what it's just doing is it's just kind of calculating the amount of moisture in a particular column. That's kind of the slightly unscientific explanation, but where you see higher values, more moisture, and sometimes hail. So, it's a good indication that there's going to be hail there. Again, that's just kind of the gloss over explanation that I don't know if my radar professor would have been too happy about, but nonetheless, you get the idea. So that's what you're seeing there. So we start seeing kind of these higher values here, these more darker colors, at least in this particular situation, as a good indication that there might be at least a little bit of hail. But again, we haven't gotten any reports of anything yet. Sometimes the weather offices, when it comes to hail, are pretty quick on wanting to confirm it. And actually, let's see here. There's something called MPing, which I'll do a little public service announcement, and I'll do it simply because it's from NSSL, I believe, is the one who does it. But there's something called MPing, and you can download it on your phone. And basically, if you see rain or hail or whatnot, you can just, hit the button and it will GPS your location, and it actually puts it onto a radar screen for some of us weather people. And it's actually something that I do kind of use a little bit. And let's see here. So there was one MPing report of about dime-sized hail right around the area that we were just looking at. Back when the storm was around Fort Atkinson, we got about 1-inch size hail with it. So that would have been a little bit ago. Quarter-size inch hail, yeah, around the Fort Atkinson area. I've seen about 1-inch size hail, and that is fun when it hits against your car when you're driving. It sounds so cool. Go out in the Great Plains and it's like 5 inches, but whatever. But that's not the point. The point is a little bit of hail with that storm. So we at least have some confirmation, albeit maybe not official, but at least some confirmation that there is probably a little bit of hail within that portion of the storm. And again, Fort Atkinson being right up here where my cursor is, and then naturally the Whitewater area. So again, kind of the area that we're looking at is going to be right around there where we see some of those higher values, but again, just a little close to the radar. We looks like we're getting at least some kind of slightly wonky readings here. Looking at here on my own phone here, and I mean it does kind of match up to what we're seeing. So yeah, about right around that area. And actually, this storm line appears like it's kind of drifting. Whoa, you don't need to see that. That's behind the scenes stuff, folks. Uh, yeah, it looks like these storms are dropping down to the southeast there. So kind of interesting there for you. We'll kind of keep an eye on it a little bit here. And another thing too that's interesting with these storm lines, and I say this not to hype it up any. If you know me, I do not like to hype things up because it takes away from the fun of storms. But sometimes with these storm lines, especially when they get stronger and when we're dealing with kind of these windy wind type of events, sometimes with these storm lines, yeah, gusty storm, squall lines. Okay, squall lines. We'll go with squall lines, or in meteorology we call quasi-linear convective systems, QLCS, is what we call them. And sometimes with those lines, you can get kind of outflow more or less winds kind of surging and different rates sometimes, and that can actually produce what's known as a spin-up tornado, which are a little tricky to actually detect. And fun fact for you, while we're on the topic, fun fact for you about those is I remember, I remember quite a few derecho events, and I remember two of them in particular that were great examples of this. Was the one in 2012, which I remember that one very well because I was still in Ohio for that. I was 2012. Yeah, I just graduated high school and was getting ready to go to college. And the next one was in 2013, which I also happened to be around for back in Ohio. And the thing about them is yes, those two derechos actually produce tornadoes. Ironically, some of the straight line winds were actually stronger than the tornado winds, so that made surveying pretty fun. And they're not normally long track; they're normally touchdown, go about a mile or two, and then go back up. When you've got dealing with all those winds and everything. And so sometimes with squall lines, you do get that. They're kind of hard to detect on radar because they're so short-lived. And it's really weird. That's why sometimes when you're dealing with a line of storms and you see those tornado warnings that just kind of pop up almost out of nowhere along the line, half the time that rotation signature is gone by the time that warning is issued. Sometimes, not always. There's kind of easier ways to detect it somewhat nowadays, but still, sometimes when you get those warnings along a squall line, sometimes the rotation just dies, halfway through the warning, and there's just nothing left of the signature. And there's kind of areas sometimes where we can kind of see ahead of time where we might get something like that, but often, we call them spin ups, and oftentimes, at least colloquially in the weather language, when I was at least where I grew up and everything with the weather offices, a spin up kind of sometimes denoted a tornado that the radar missed. It happened so quickly. It happened in between radar scans, and no one would have known it happened if it didn't hit anything. And so yeah, that's what a spin up tornado kind of means. Just something very brief, something very short lived, and they're typically not strong. Well, they're typically not, the big F5s that you see in Oklahoma or, down in the deep South. They're typically, just those little whoop, knock out a few trees. But again, when you're dealing with squall lines, sometimes with, 80-mile-an-hour winds or even 90, or in the case of, what was it, the one in Iowa a couple of years ago, 120-mile-an-hour straight line winds. Typically, it's a little hard to decipher what's the tornado and what's actually the straight line winds, or if there even was a tornado. And sometimes the only clues that you have Because I know a lot of times this happens a lot in Ohio, and I'm sure it happens probably where you live. Whenever like a squall line, a strong squall line or a derecho or something comes through, people always say it was a tornado. They're certain it was a tornado. Well, one of the things that we look for in meteorology is the way the damage is laid out. If all the trees are down in one direction, it's probably straight line wind. Not just in one house, but like over an entire area. I mean, if all the trees are down in one direction, that's a good indication it was straight line wind because tornadoes they rotate. Debris tends to be kind of scattered more or less, or at least kind of focuses in on a particular point. I can't remember what the mathematical term for that is. Like, like cycloid? I can't remember now. There's an actual word for it, but that tends to be tornado damage. Straight line winds don't normally do that. So yeah, that's just one thing. But anyways, just a little fun fact for you there. That's one of the things that we actually look for in meteorology when it comes to surveying damage. So I'm taking a look at the storm line again. It looks like maybe it's that particular storm is kind of morphing at least a little bit into just kind of a very localized little line there. It doesn't seem to have some of the signatures it had earlier. Earlier, we were watching one that was in Michigan. Now, again, I'm thinking here that the majority of the activity here this evening is going to be, at least the early evening, is going to be across Michigan. And actually, we may have a little bit of luck here. I'm going to switch the screen here in a second. Don't worry. I know some of you guys are still seeing me. I'm just setting up the radar and don't want to make everyone sick, seeing all the moves and everything. Let's take a look here back over at Grand Rapids. And once again, we happen to get kind of lucky in that, their storms are really close to the radar site. Sometimes we're not always that lucky. And weather, there's just not a lot of, there's a lot of radars, but you know what I'm talking about. They're not always close to the storm, but in this case it is. And what's interesting here is we may have is this a camera? We may have, right outside of that storm line. There's 55, 56 people watching it, and including us. So, it happens to be one of those storm chasers. All right, it looks like they're probably looking at what might be, and I have no idea, Brandon Kopic, I don't know. These chasers do nowadays. Some of them are a little crazy in my opinion, but that's, crazy not in a good way. But that's not the point. They get in the way of scientists like me trying to actually do legitimate stuff sometimes. But that's besides the point. I mean, sometimes they are helpful, but sometimes they're also in the way. But anyways, moving rapidly along, I digress. My guess is this guy is going towards what looks to be, well, at least it kind of looked to be a little bit of a radar signature, or he might just do what I like to do, and that is sometimes to drive right through the storm, regardless of what it is, to kind of see what's going on with it. So you can ask my fiance, you can ask a lot of people, or actually, yeah, I've dragged how many thunderstorms and squall lines and wall clouds and you name it. She has unfortunately had to go through it with. She's had to ride it along with me there. But anyways, moving rapidly along. I could just be doing what I like to do sometimes. But Anyways, so he's coming up. He's moving northwards right now, and it looks like I don't know where he's trying to meet this storm. If we kind of zoom in a little bit here, I have no idea, like I said, who this guy is. I don't even know if he knows that we're watching him. So there you go, a little free publicity here for this guy. But looks like he's at least moving northwards, and I'm curious as to if he's going to turn onto the onto 96. He's going to turn onto 96 and maybe try to meet that storm around the Walker area, or if he's trying to catch up with this tiny little notch that is right to his northwest. That's kind of what I'm assuming he's probably going to go check out. You can see the shelf cloud on that video here. It might be a little small. Maybe we can enlarge it a little bit. It doesn't look like we can do that, but you had a good shot of the shelf cloud of this thunderstorm, which is, of course, that cooler air kind of forcing that warmer air up. and it gives it that shelf-like appearance that you see a lot of times ahead of thunderstorms. And that, you know, these lines, folks, these lines sometimes have some of the coolest looking shelf clouds, you know. So he had a good shot of it there earlier on in one of his videos. Certainly he's running into some lightning. I would hope so if he's driving into a thunderstorm that there'd be lightning. Otherwise, it would just be a rainstorm. But again, it's a little bit hard to see, and honestly, probably, folks, all you see is pixels, to be quite honest, on your guys' end here. But there is a nice little wind burst that he actually may hit, and that may be what he's going for, because he looks like he did. No, he turned off, but there is a nice little wind that we're looking at, and it's right here around the Walker. I'm curious as to maybe what the radar is thinking. Of course, mind you, the data that the radar is reading is a little higher up, so it's not necessarily always affected by the land, so sometimes you have to subtract a few miles an hour for it. But let's just see what this guy here has, or at least not the guy you see in the video, but the storm. That guy, that's who I'm talking about. There could be about some good little 64, 65 mile an hour, so maybe about 60 mile an hour winds that looks like might be heading right his way. So we may get a kind of a good shot here conveniently, and see, this is why I've said it before, I like to go out in all storms. You never know what you're going to find with them sometimes. You know, some of the most interesting storms I've driven through weren't even warned. So we'll see here what this guy, and again, I don't think there's a way I can make this picture any bigger, but you know, for now we'll just kind of keep him up there. I just want to see, you know, if this guy gets a good burst here of wind. I'm curious as to why he got off the interstate. But then again, I'm not the one driving. So, and all we're looking for, folks, so in case you're wondering where this guy is this little icon right here that you see where my cursor is. In both cases, you're looking at the same location, just two different types of radar with it. And so that little dot right there is where he is. And this bright thing you see here on your right around Walker, this little area thing right here is a little burst of wind here, about maybe 60 some mile an hour wind gusts. And so kind of wonder if that's what he's going, if that's what he's, no, because he keeps going north. Turn around, dude. There you go. All right. So see, telepathic right there. So the only reason we're watching this video is because I just want to see, you know, we kind of see what the radar here is picking up. And again, it's picking up probably, you know, the data points that it reads on the radar is about 65 miles an hour, 67, a little higher up here in the storm. So you might want to subtract a little bit of that for friction, at least a good 60